So, first question to you here, alright? I'm just going to give you a few examples of using this multiplication or fundamental counting principle, and eventually get into the word permutations as to what they mean, and show you kind of they're very similar. First question to you is, how many different 3-letter passwords could I make if no repetition is allowed? Okay? How many different 3-letter passwords could I create if no repetition is allowed? And let's even say it's not case sensitive, okay? It's not case sensitive at all. Alright? So I'm going to make a 3-letter password. Well, that's tough, right? 3 letters. All you got to do is get the right 3 letters. Okay? Shouldn't be too tough to figure out. Okay? Well, how many different 3-letter passwords are there if no repetition is allowed? What would you have to do to figure out how many total passwords could be created using 3 letters? Kevin?
You can take like 26 times 25 times 24.
And see what that number is?
Yep.
Okay. Why'd you say those numbers? 26 times 25 times 24.
How many letters are in the alphabet? You can just take it times 1 less 2, can't repeat it.
Okay? So you're saying I have 26 different letters to choose from for the first letter, but then because I can't repeat it, I only have 25 letters to choose from for the second letter in my password, and then I only have 24 letters to choose from for the third letter. So 26 times 25 times 24, and whatever that equals, you're saying is the total number of 3-letter passwords you would have? Does that make sense?
Yeah.
That's very good. Okay. What is that answer? Anybody with a calculator?
15,600.
15,600?
Okay.
Okay.
After like 3 guesses.
15,600 passwords. So, if you wanted to bust into my computer and you knew it was just a 3-letter password, okay, you still would have to figure out which of those 15,600 orders of letters that I used for the password.
That's if you don't have any.
And that's if nothing repeats. How would this change if repetition was allowed?
It'd be 26 times 26 times 26.
26 times 26 times 26, absolutely.
So that'd
Be a few more. Okay? It'd be a few more. Not a lot.
No, 2,000.
Another 2,000?
a lot.
Okay.
Not a lot.
Well, in the whole scheme of things. Okay. And this is a 3-letter password. Okay? How many of you are, well, first of all, I don't even know if you can have 3-letter passwords for a lot of things. Most of them require at least 4, 5, 6. You can have characters, you can have numbers, it can be case sensitive. I mean, if all those things start taking place, all of a sudden, there's a massive number of potential passwords somebody could have for whether it's a phone or a computer, log into a bank account or whatever it might be. Okay? And obviously you would need computer programming to run all those different permutations to see if you can find the right code. Okay? But, do you guys see how we just used that counting principle again though? Alright, everybody good on that? Okay? Let's do this one. License plates. Okay? On an Iowa license plate, on a standard Iowa license plate, standard one, you have 3 letters followed by 3 numbers. Okay? 3 letters followed by 3 numbers. How many different license plates could there be then?
You take 26 times 26 times 26 times 10 times 10 times 10.
I don't think it'd be 10, it would be 9.
It'd be 9. It'd be 9.
Oh yeah, it'd be 9. No, it'd be 0. Yeah, it'd be 10. It'd be 10.
So you're saying 26 times 26 times 26 for the 3 letters, right?
Yeah.
And then 10.
And then for the numbers,
10.
10? Are there 10 digits?
Yeah.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9?
Yeah.
Okay? We're assuming that you can repeat digits or repeat letters here, obviously.
So once you figure out like what the both of them are, multiply them out, and you multiply them together, then you have,
Or just multiply all the way across even.
yeah.
I mean, because these go with these, so just 26 times 26 times 26 times 10 times 10 times 10. Anybody?
That's a big number.
Really big number.
175.
It's 17,506,000.
That is why everybody has a car license.
So, there are over 17.5 million different license plates that the state of Iowa could potentially use, which that should be enough, means we only have about 3 million people. Okay, and I doubt everybody owns 6 vehicles. Okay, then we would run out. Plus there's customized plates. Now I will take this back. There are some that won't be allowed.
Like what?
Well, you probably can't go ASS to start with. Okay, or use whatever other vocabulary you want. Okay,
Is that by word?
okay. It's like angle side side in geometry.
Yeah, angle side.
Yep. Okay. So there are some things you can't or won't have on license plates. All right. Even the standard ones, there are some combinations of letters that are not used. Okay. Plus, when you make your own license plates, if you customize them, there are some things you can't put on your license plate.
No, I know
Okay.
that's bogus. You're paying for it. You should be able to put it there.
No.
Yeah, but so we have to do something.
Yeah. As little kids.
We're good.
What's that mean?
My
Or
mom
the
doesn't
cop,
work on
you got a
license
cop
plates.
on your license plate. Yeah, run the license plate. I love.
All right. Okay. So, glad this is on video. That's nice. So anyway,
Oh, well,
this.
it's only going on YouTube.
Yeah, I know.
Really
The
famous.
teacher's cussing.
I love Kung Fu.
I'll be fired next week.
Oh, darn.
Yeah, I know. Don't cry. So roughly, all right. Given that different things might be taken away, but over 17.5 million different license plates could essentially be created. Okay? Alright, so that's the whole idea of this multiplication counting principle. Now, let me change gears here a little bit. Let's say I was going to take the letters in Burke's first name and arrange them. How many ways could I arrange the letters in Burke's first name?
5 times
Please for Burke.
Not quite.
26 times 5.
I'm just using the letter, his letter.
26 times 26 times 5 times.
Gavin got it.
120.
How many letters are there?
5.
5. How many letters could go in the first spot?
5.
Next spot? Next spot, next spot, next spot. 5 times 4 times 3 times 2 times 1, right? Okay? Because I only have 5 letters to choose from. Alright? There's 5 times 4 times 3 times 2 times 1 different ways that I could arrange them. Okay? Because I'm using the same idea here, right? I mean, everybody see how I'm using the same idea? It's pretty important. But I only got 5 letters to choose from. A B, a U, an R, a K, and E. Okay?
It's the same thing.
So, it's the same sort of deal. So 5 times 4 times 3 times 2 times 1. Alright, 120. So I could arrange the letters 120 different ways. Okay?
Somebody has like the same letters.
We get to that here in a minute. Okay? Maybe not today, we'll see.
That's not today.
Alright, next. Here's my next question to you. What if, how many ways could you arrange all 26 letters?
A lot.
Correct, but not very exact. What would you have to do mathematically? Don't do it. 26 times 25 times 24 times 23, all the way down to 1, right? Okay? That would take a long time. In fact, it'd be a big number. We'd probably even screw up writing that number down. Okay? There's a chance,
You can
anyway.
only go to 2.
Okay? Now, what we can use instead of that, okay?
Oh,
Permutations.
where's this like?
I'll come back up to permutations in a second. What we can use instead of that is this exclamation point. Factorial. Okay? Factorial. Instead of taking 4 times 3 times 2 times 1, you could take what's called 4 factorial on your calculator. Okay? Or you could even just write 4 factorial as far as I'm concerned. If I would say, how many ways can you arrange all 26 letters in the alphabet? 26 factorial. Okay? Instead of actually figuring that out.
And that's the answer we use.
Okay?
It's a big number.
For that, yeah, I'd be fine with that.
Alright.
Instead of that huge number, because it's probably going to be in scientific notation. It's so
Please tell
long.
me there's going to be a question like that.
Okay. Now, so this factorial, this exclamation point, all right, first of all, means factorial. All right, when you see this, please say factorial. This says 4 factorial. It does not mean 4. Okay? It does not mean say with lots of emphasis, all right, and get excited, okay? Okay, 4 factorial. Here's what it kind of means mathematically. If you have n factorial, like let's say we had 8 factorial, it means you take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? Any number factorial, and by the way, this number has to be a whole number, all right? You can't type in like 10.6 factorial. The calculator will ask, or will say error on that, okay? N factorial means you take the number n times the number that's one below it times the next number that's below it all the way down to 1, okay? So when I said how many ways can you arrange the 26 letters in the alphabet, it would be 26 factorial. And I'd be fine with you just writing 26 factorial, okay? 8 people are going to run a 400 around the track. How many ways could they finish? 8 factorial. A whole bunch, right? They can finish a whole bunch of ways. Okay? Now, they're only going to finish one certain way, but how many different ways could that happen? 8 factorial. Because how many people could finish in first?
Well,
8.
you'd have to subtract 1 because I automatically give first every time. So.
So like 7 people are racing, technically.
Alright?
Yeah.
So,
Pretty much.
that's factorial. Where is the factorial? Okay? Depends on the calculators, but if you are using graphing calculators, here's where you find your factorial button. Because sometimes you're actually going to have to get the number, not just leave it as 26 factorial. You hit math, okay? You hit math, and then you go over to PRB, kind of on the top there. You hit math, and you go over to PRB,
4.
and then you'll find the exclamation point, the factorial,
4.
okay, on your screen. So let's say you wanted to do 6 factorial. Okay, if you want to do 6 factorial, you got to type in the number 6 first, then hit math, go over to PRB, and then down to factorial. Okay,
720.
720. Good. Okay. If you don't have a graphing calculator, you're going to have to find that exclamation point kind of on your own. I can help you out if you're struggling with it. Okay? But that's what factorial is. Okay? You can use it when you're going to take a number times itself all the way down to 1. How many out of time, Jake?
You got 13 minutes.
Better pause.
Oh, we gotta wait.